what is this universal set? A universal set contains all the elements of all the sets without repeating any of the element. Now let us understand this through a example. Suppose you have a school. Now it has grades 1 to 12 in it. Now grade 1 students would form one set, grade 2 students will form another set, grade 3, grade 4, and so on. All the grade students will form one different set. Now all these belong to the school. So here school will be called as a universal set, and the elements are not repeated again. Okay. Now whatever students I have in grade 1, I may not have in grade 2. Grade 2 students will not be there in grade 3. But this may not happen when we are going for a mathematical problem. Suppose I have a set of numbers. Suppose this as a universal set. Okay, it may be having numbers 1 to 10. Again, I may be having another set having numbers 1 to 20. But when I'm representing a universal set, I will not repeat these two sets 1 to 10 again. I will not start over from 1. I will start from 1 and I will end it at 20. This is what my universal set looks like. I will not be repeating the numbers when it comes to my universal set. Okay. Now, how is this universal set represented? This universal set is represented by a capital U usually. Sometimes it is also represented by a capital E. Now, moving on to the next concept, that is intervals as subsets of R. Now, let us see how it's been a long time since we wrote set builder form, isn't it? Now, let's denote few numbers in set builders form. We'll come to this number line and all these lines explanation. But let us take two numbers. Let them be A and B. They are any real numbers wherein A is less than B. My number A is less than B. Now I am trying to write it in set builder form. So let's see how I do it. The set of all X such that X is a number greater than A but less than B. So now if I'm saying X is a number greater than A, that means A will not be included, but all the numbers after A would be included. And now when I say less than B, B will not be included, but all the numbers preceding B would be included. Now, this can be represented in the form of open interval. Now, let us see what is this open interval and why are we representing it in the form of open interval. Now, this instead of writing whole of this big sentence, I can simply write it as A comma B. Now, these A and B are called as my endpoints. What are these called as? Endpoints. And here, the small brackets means open interval. What do you mean by open interval? When I say open interval, that means this endpoint A and endpoint B is not included, but all the elements or the numbers between A and B are included. Now, let us understand it through an example as to what exactly is open interval using an example. Now, if I write open interval 4 comma 8, now what does that mean? 4 comma 8. What did I say? When I say open interval, the number 4 will not be included. The end point will not be included. I will have all the numbers in between. Now again, there is an open interval at 8. That means I will not be including 8. So when I write it like this, open intervals 4 comma 8, that means it is the numbers 5, 6, and 7 that I am talking about. Now, there is something also called as closed interval. Now, what do you mean by closed interval? Let us come to that. Now, first, let us write it in the form of a set builder form. Now, when I write it as the set of all X such that X is less than or equal to A and less than or equal to B, that means my A is also included and my B is also included. If I say X is greater than or equal to A, then will I not include A as it says equal to A? Now, when I say less than or equal to B, that means my B will also be included and all the numbers between A and B are also included. Now, this is called as closed interval. Now, this representation is written in the form of closed interval. Okay, now what do you mean by closed interval? When I'm talking about closed interval, I'll be using the square brackets. Please remember, when I'm talking about open interval, I will be using these small brackets, and when I'm talking about closed interval, I'll be talking about square brackets. And in the case of closed interval, A and B are both included. Now let us understand this through an example on a number line. Now suppose I am saying closed interval 9 comma 12. 9, again I will have to use a square bracket. When I say 9 comma 12, I said close interval. So 9 comma 10 comma 11 12. These two endpoints that are 9 and 12 will also be included. I hope that's clear. Now move on to. Now there is a possibility that one endpoint could be a closed interval and the other endpoint can be an open interval. Let's see if that's possible and see how do we represent if it is one is closed and other is open. Now, let me first write it down in set builder form. The set of all x such that x is less than or equal to a and less than b. Now, when I say x is a is less than or equal to x less than b, that means x is greater than or equals to a and x is less than b. Now, when I'm saying greater than or equal to, A has to be included. That means it will be a closed interval. When I say less than B, that means B will not be included, but B would be excluded. Will this be a closed interval? No, it will not be a closed interval, but it will be an open interval. Now, how do we read it? Now, I will read it as this is an open interval from A to B, including A but excluding B. Okay? Because it is a square bracket, I will be including A but excluding B. Now, let me take two numbers. -1 is a square bracket, 4 is a small bracket. That means what are numbers can I take from this? -1 as it is a closed interval. 0, 1, 2, 3. Can I write 4? No, I cannot write 4 as it is an open interval. I hope you understand. Now, similarly, if I write the set of all x such that a is less than x less than or equal to b. That means I am saying x is greater than a and x is less than or equal to b. Greater than a means a will be not included, so this will come as open interval. When I say less than or equal to b, b would be included and it would be a square brackets. I hope now you have seen the representation. One is a small bracket, the other is a square bracket. Now let us represent this. Now suppose I take open interval, close interval. That means 5 will not be included. 6, 7, what about 8? 8 is a closed interval, so it would be included. I hope the explanation is clear. Now, let us understand this. Now, see here, again, this is a number line representation where this open circle means we are talking about open interval. A, comma B. A and B are excluded. Now, when I say, see here, A and B are shaded. That means it represents closed interval. Now again, A is shaded, closed interval. B is unshaded, so open interval. Again here, B is shaded, so closed interval. A is not shaded, so it would be an open interval. Now, I hope you have understood. Now moving on to how to find out the range or the length of any of the intervals. Now, if I want to find out length of any of the intervals, I just have to subtract b minus a, be it for any of the intervals, both open, both closed, one open, one closed. I just have to subtract. In this case, 8 minus 4 would be my interval. In this case, 12 minus 9 would be my interval. Here, 3 minus of minus 1, it will be in my interval. And here, 8 minus 6. Always remember, b minus a would be the interval. Now, I hope that's clear. Now, let's move on to the exercise 1.3. Now, let us solve few problems from exercise 1.3. Not all problems will be solved as earlier. We'll be solving few of the problems, and the rest which I will not be solving will be given as homework, or you can practice it at home. Okay, now let's get started. Let's read the first question. Make correct statements by filling in the symbols. What symbol is that? What symbol is that? We have already learned this is a subset, and the other symbol is that of not a subset, right? Now, this symbol is for subset, this is for not a subset. Now we know what is a subset. Yes. Now let us have a look at the first problem. 2, 3, and 4. Are they subset of this? Yes. 2, 3, and 4 are also present in my other set. So it is a subset. Now moving on to this. A, B, and C. Do I have A, B, and C here? No. A is missing in this. So I can write it as not a subset. Now, moving on to third and fourth will be given as homework. I think you can do it. Fourth is similar to fifth and sixth now. Now let's go for fifth. The set of all x such that x is a triangle in a plane. Okay. Now, the set of all x such that x is a rectangle in a plane. Now, suppose this is a plane. My triangle can be here. My rectangle can be here. Triangle is not inside the rectangle. Okay, so I will have to say that it is not a subset. Triangle is not contained in my rectangle. It could be anywhere in the plane, right? Similarly, set of all x such that x is an equilateral triangle in a plane and x is a triangle in the same plane. Now again similar, these two triangles can be anywhere in the plane. Now this could be my equilateral triangle and this could be my other triangle. They could be anywhere in the plane, not necessary that one equilateral triangle is contained in the other triangle. So no, this is not a subset. Again, let me do this last one from the first bit. Set of all x such that x is an even natural number and set of all x such that x is an integer. Now, we all know that natural numbers is a part of all my integers. What are my integers? Negative numbers, 0, and all my positive numbers. What are my natural numbers? They begin from 1. So all my positive numbers are integers. So obviously, it is a subset. I hope this first bit was clear. Now, moving on to the next bit. Examine whether the following statements are true or false. Now, A comma B is not a subset of B, C, and A. We already have the elements A and B here. So this is false as it is a subset. Next, A comma B, A comma E is a subset of vowel in the English alphabet. Yes. What are my vowels? A, E, I, O, U are my vowels. So this is absolutely true. Now, I think you can go for third one. Third one will be given as homework. Let me do the fourth one. Again, fourth one also will be given as homework. I think these are similar. You can go for it. Now, fifth one. What does it say? Set A belongs to set A comma B comma C. if you recall, we were writing elements when we were writing belongs to. We were not writing set. When we were discussing about vowels, I was writing A belongs to the set of vowels. Yes, I never wrote A in the form of a set. This is a wrong representation. A is not a set. When I'm writing belongs to, I'll have to write each and every element. I cannot write it in the form of a set. This is a set, right? No. When I'm talking about element, I'll just have to write element A belongs to this set, but not set A belongs to this set. This is false. Hope you have understood it. Now, moving on to the next question. X is a even natural number less than 6. What are my even natural numbers less than 6? 2, 4. And X is a natural number that divides 36. I have many numbers that divides 36 and 2 and 4 are included. So this is true. Yes or no? What are the numbers that divides 36? 1, 2, 3, 4, 6, 9, 12. So 2 and 4 are already included in it. So yes, it is a subset. Now, moving on to the third question. Let A equals to the set of 1, 2, again the set of 3, 4, 5. Which of the following statements are correct and why? Again, I will not be doing all the problems from this. Now, please remember, these are the elements, okay, of the set. Now, 3, 4 is a subset of A. They have written it as set. No, it is an element. So I will have to write belongs to instead of subset. Please be clear with this. I cannot write it as this is one. Suppose replace it bit by big O. Okay. Now, can I write O is a subset of A? No, I cannot write. Can I write it like that? No. I will have to write O belongs to A. Yes or no? Now, let us, so this is incorrect. Now, moving on to 3, 4 belongs to A. Yes, this is correct. Now, consider this as O. So, O belongs to A. Yes. Now, third one, yes. Now, this is the correct representation. Whenever I am representing a set, see, suppose this is one whole set O. Now, I am writing it in parentheses. O is a subset of A. Absolutely. What is O? O is again my brackets containing 3 and 4. So, this is absolutely right. I hope you have understood the difference. Now, 1 belongs to A. True. 1 is a subset of A. Can I write 1 is a subset of A? I will have to, a set is a subset of another set. Element belongs to the set. Please get this clear. Okay. One element belongs to the set. But when I am writing subset, I will have to write one set is a subset of another set. So this is wrong. I cannot say an element is a subset of another set. I will have to write belongs to. Now, this will be given as homework. I think I've almost done all the problems from this bit. Now, in case you're not understanding, please leave the comments below in case you need help with any of the problems. Now, again, moving on to, oh, we have few more problems here. Third bit, seventh one. Now, what does the seat 1, 2, 5 belongs to A? Can I represent, when I say belongs to, I will have to write it in the form of elements. I cannot write it in the form of set. It is not the correct way of representation. Now, 1, 2, 3 is a subset. Yes. So this becomes a set. Set is a subset of another set. So this is correct. Now, your ninth one. Null set belongs to A. A set does not belong to another set. Element belongs to a set. So I should have written, so this is wrong. This is the correct way of represent. A subset is I'm sorry, a null set is a subset of another set. One set, subset of another set. One element belongs to another element, another set. Now moving on to 11th one. Again, can I write it like this? The 9th one, it is already a subset. Then why am I again representing it is like this? No, this is correct. This is again wrong. I cannot represent null set in another bracket. Okay, this is wrong way of representation. We have already seen the correct way of representation in our first video. So please go through it. Now, moving on to the fourth bit, write down all the subsets of the following set. Now, let us start with the first problem. Now, I have to write the subsets of A. Always remember, null set is a subset of every set. So whenever you are asked to write subsets, always include a null set. Also, every set is a subset of itself. So these two sets will be mandatory apart from the individual elements. Okay. So the first is, as it is just a singleton set. We call it as a singleton set, if you remember, as it contains just one element. So phi is a subset of every set. And yes, every set is a subset of itself. Now, second one will be given as homework. Let's go for third one. Now, I have to write down all the subsets. What did I say? Always remember this. A null set will be a subset of every set, and also the set itself will be a subset. So these two sets are mandatory whenever you're writing any sets. Now, apart from that, what all sets can be formed? Set with element 1, set with element 2, a set with element 3. Now, set with element 1 and 2, set with element 1 and 3. Yes, and any other possibilities? Think of it. Yes, set with element 2 and 3 is also possible. So, this is my subset. Again, fourth one. What do I have? Null set. I cannot write anything else. So again, null set itself is a subset of itself. Okay. Now moving on to, you only got one problem as homework, but do practice the example problems that are given in the textbook. Moving on to fourth bit, write the following as intervals. Now I have to write it in the form of intervals. Now x is greater than -4. As it is greater than -4, I will have to use the open interval, as -4 will not be included. Now x is less than or equal to 6, equal to 6, 6 is included. So I will close it with a square brackets. Now again, this one would be given as homework. Now moving on to the third bit. I have 0 less than or equals to x. X is greater than or equal to 0. That means it will be a closed interval. And x is less than 7. 7 is excluded. That means I will have to put a, I will not put a square bracket. Instead, I will put a circular bracket or a small bracket. Now, I think again, you can do the fourth one. Fourth one will be given as homework. Now, moving on to the sixth bit. Oh, we do have seventh bit as well. So let's do our sixth bit. Write the following intervals in set builder form. I think we can do that. Yes, so let's get started. Now, it is my open interval, so that means it is not included. I will write it as the set of all x such that x is less than -3 less than x less than 0. Am I including equal to here? No, because why? It is open interval. Now in this case, now this will be given as homework. This will also be given as homework. I will do the last bit. Now, if you see here, x, the set of all x such that x will lie between -23 and 5. Now tell me, what sign should I put here? As it is a closed interval, it would be less than or equal to. as it is an open interval, it will just be less than. I hope that is clear. It is minus 23x minus 23 less than or equal to, because it is a closed interval. Now, the seventh one, the universal sets would you propose for each of the following? What do you think is the universal set to set of right triangles? A set of all the triangles, a set that contains all triangles would be a universal set to set of right triangles. Yes. Now, I think this would be given, again, this would be given as homework. You have to find out the universal set to this. Now, what do we have to do in this eighth problem? Given sets 1, 3, 5 and B 2, 4, 6 and C. Which of the following may be considered as universal sets for all three sets A, B, C? Okay. Now I need to write a universal set of A, B and C altogether. Let's see. It should contain, what is a universal set? It should contain elements of all the related sets without repeating. Let us check. Now, 1, 3, 4, these are odd numbers, even numbers. And so now what are my numbers? Let us write down here. 0, 1. Next, I have 2 in B, 3, 4, 5, 6. Do I have 7? I do not have 7. So it should at least contain these elements. When I am talking about a universal set, it should at least contain these elements. Now, let us see. 0, 1, 2, 3, 4, 5, 6. My 8 is missing. So this cannot be a universal set. A null set does not contain anything. I need to have at least these elements in my universal set. Now, let us go for the fourth one first. 1, 2, 3, 4, 5, 6, 7, 8. 0 is missing. So this cannot be. Now 1 is remaining. Let's see if that could be a universal set. 0, 1, 2, 3, 4, 5, 6. 7 is extra. 9 and 10 is extra. Of course, it can have more elements than those present in your sets. The condition is it should contains all the elements without repeating. So that is being met. I hope it is clear for you all. Yes. Now, that's all for today. I hope you found the lecture understandable. If you have any questions or any doubts, feel free to post it in the comments. Keep us asking. Goodbye.